So a lot of the research I do walks the line between basic research and applied research. And applied research is really done to help society now. And so some of the information that I really focus on, like how do systems respond to disturbances, is important, especially for land managers, because they have to make the decisions on what to do once a particular disturbance has happened, whether or not they should interfere with recovery. And so some of the stuff that I do can give them an indication of whether they should interfere. And so some of the fires that I work in out west, one of the biggest issues that we can see, which will limit how quickly systems will recover, is how the size of large treeless openings that are created by certain wildfires. And so if I evaluate where the trees exist on the landscape using different detection techniques, then I can say, if you have a limited amount of resources to do any recovery efforts, you should do it in this location because it would give you the most benefit. It would enhance the recovery of the ecosystem the best. And so the research that I do can give land managers information about how to prioritize the resources that they have to make a significant impact. So this study actually led to the development of more landscape, wetland landscape type models. And so before, DACENT was really used for agricultural systems and forests, but it was really useful to use this model, making certain tweaks to it for wetland systems. And so they did come out with a wetland version that had even more modules in it that allows you to like model how water moves through a wetland system, which is quite important for how it's going to function. And so it really led to the development of wetland models, which is really important because if you look globally, there aren't that many wetlands. It's like 8 to 10% of land surface that is in the wetland state, but it has a significant amount of the global carbon in these systems just because they store and accumulate carbon so much. And so even though it's a small land area, they have a huge impact on global climate dynamics. And so now that there's all this interest in wetland model, and a lot of that is just because people are trying to adapt terrestrial models to wetland systems, now they're actually developing models that work best in wetland ecosystems. Yes, there were a lot of things. There are always a ton of things left unresolved for this paper. And so we could have taken all the possible futures and modeled them, right? And so if I had focused my entire PhD work on just this one chapter, then I really would have modeled all the possible futures to really get a good understanding of what the potential of these sites could be. But we just modeled 3 futures. And so it'd be interesting to know if the assumption that if you model the extremes and then the mid, that would give you an idea of what the possible futures are, but you don't know that until you actually go to model them. Mm-hmm. And so I think that would be a really interesting exercise to do, to see how well the assumptions line up with what would happen if we actually modeled the futures, if there would be any surprises there.